Hello everybody. We are going to continue with energy expenditure, with the mechanisms of energy expenditure, and today, or the next one in line, is thermic effect of food or diet-induced thermogenesis. We abbreviate as TEF and DIT. So what is it? What does it mean, thermic effect of food? So it refers to the increase in energy expenditure after a meal. In other words, in order for your body to digest, absorb, transport, and deal with everything, all the nutrients that are present in food, it has an energy cost. And this can be reflected in an increase or in a release of heat after you eat. And that's why it's called thermic effect of food, because after you eat, obviously this can be a very small alteration, but it's there, it's measurable. If you were to actually measure body temperature after you eat, you see that there is a slight increase, slight oscillation in body temperature. So that energy that is released is because of all the processes involved in breaking down the food, absorbing it, transporting, and dealing with it inside of our body. So that's what characterizes thermic effect of food. And obviously it changes depending on what kind of food you eat. Some foods have a higher thermic effect, others have lower. And for instance, if you compare protein with fat and carbohydrate, protein tends to have the highest thermic effect of feeding because the digestive process and the entire breakdown and metabolism of proteins is very costly. So there is a higher energy cost or production or energy consumption better to diets or foods that contain more protein as opposed to carbohydrate and fat that have a lower energy cost to be processed and metabolized. So, but in general, if we were to put a meal that is mixed with different foods, the thermic effect of food accounts for approximately 10 to 15% of the total daily energy expenditure. It's a fraction. It's approximately 10 to 20 or to 15% of the entire energy expenditure in a day. And obviously it varies if you eat one meal a day, 2 meals a day, or 3 meals a day, or if you eat every 2 hours. That will have a different impact in your energy or in your thermic effect of food. So it depends on obviously how often you eat, what kind of foods you eat, and how much you eat. So all these different things can affect the thermic effect of food. But in general, it ranges between 10 and 15% of your total daily energy expenditure. It can be divided in two parts. We can call obligatory, which is the energy expended for digestion, absorption, and storage of nutrients. In other words, there is no way you cannot escape that. It has to happen every time you eat something because you cannot escape digestion, you cannot avoid the absorption and storage of nutrients. So everything that is essentially related to processing the food in your body, you have to go through. So that's why it's called obligatory. Now there is another component to it that we call facultative, and it involves the activation of the sympathetic nervous system and thermogenesis. But that depends on what kind of nutrients you have in your food. So depending on what kind of composition in your diet, you may have more, or you will require the activation of specific mechanisms. For instance, when you have a high amount of protein, as I mentioned, that has a higher activation of specific metabolic pathways that will have an energy cost. But if you have a diet that has lots of carbohydrate, for instance, that activates the sympathetic nervous system. That alone by itself activates the sympathetic nervous system, and that has a thermogenic response. So facultative is because not every food that you eat contains the same type of nutrients. You may have some Or you could have a diet that is exclusively made up of protein and fat, but very little, almost no carbohydrate. If you eat only meat, for instance, that's a case. But you could also have other foods that contain mostly one particular nutrient. For instance, if you eat rice is basically carbohydrate. So you're restricting the metabolism only to those specific steps of digestion and absorption that are related to carbohydrates. So the facultative means that it depends. It's not always. It can vary depending on what kind of foods you are eating. So that is again the effect of food, what you eat, on your energy expenditure on a day-to-day basis. There is another one called adaptive thermogenesis, and this is not very, it's not all frequently very spoken about, but has a very important implication to our energy expenditure. So adaptive thermogenesis represents the energy dissipated in the form of heat in response to environmental changes, such as exposure to cold and also dietary alterations. What do I mean by this? I think it's very easy to understand that if you go outside in the winter, it's cold, your body has to maintain your temperature, and for that you need to accelerate, you need to break down some substrates to produce heat. So you can shiver, you can contract your muscles. So there is a way for your body to actually produce heat, but that alone requires energy. So in other words, you consume energy to produce heat. So that's relatively easy to understand, and that's what we call adaptive thermogenesis, because you're adapting to the environment. That's again easy. Same thing if you go to a very hot and humid environment. Your body now doesn't have to produce heat, but it has to mobilize different mechanisms to be able to dissipate heat or to send heat out, so you can maintain your body temperature within a relatively narrow range. So these are adaptations that occur depending on what kind of environment you are. But that's not the only one, and I think probably not the most important one, because there is also dietary alterations that affect adaptive thermogenesis. What do I mean by this? Let's say you go on a diet because you want to lose weight. So what you're going to do is you're going to eat less. You're going to restrict the amount of food you eat. In other words, I'm going to restrict my calorie intake. Let's say you spend approximately 2,000 calories a day, but you're going to only eat 1,000 calories a day. You're going to cut it by 50%. You're going to only eat half of what you need in terms of calories. Obviously, you're going to have a deficit of energy. Your body's going to be you're going to have to find a way to deal with that deficit. If it's not coming from the food, where do we get that additional energy that is not coming from the food? So then your body goes and starts mobilizing the adipose tissue. Now what happens is that as time goes by, if you keep eating only 1,000 calories, but you're spending 2,000, that 1,000 deficit, your body senses it and says, well, look, we cannot go this, or there are mechanisms in our body to sense this deficit in energy and start to adjust so it doesn't go continuously with that big gap of energy compared to how much you eat versus how much you spend. In other words, what your body does is, okay, if you're getting only 1,000 calories a day, we're going to try to adjust our energy expenditure to be as close as possible to that amount of energy that is available. In other words, if you were spending 2,000 calories before, now with the adaptive mechanisms that are mobilized in our body, you start spending less. So you go down to, let's say, 1,700, and you may even go down to 1,500. In other words, you think you're spending 2,000 calories as you thought before, but now your body, to protect itself, it lowers its metabolic rate. So your heart slows down, your liver, your kidney, all the organs that are really responsible for maintaining your metabolic rate, they tend to be reduced because your sympathetic nervous system is actually inhibited to a certain extent to attenuate or to reduce energy expenditure. So there is a direct relationship not only with the environment that you are, if it's cold or hot, but also with the how much energy is available in your body. So if you have abundance of energy, your body is okay. There is no need for it to restrict or to reduce energy expenditure because you have lots available. But now, if you're chronically exposed to a condition where your body is limited in the supply of energy, it will try to adjust itself to be as close as possible to minimize the gap between what you take in and how much you spend. So why do I say that this is important? This is important because it has a lot to do with the weight loss approach. If you want to lose weight and you calculate how many calories you're spending, and you say, we're going to have a deficit of 500 calories every day. And what happens is that after a month or 3-4 weeks, a month, what happens is your body had enough time to adjust itself. So instead of spending 2,000 calories as you were before in the beginning, now it's spending less. So your weight loss actually plateaus. Plateaus because your body said, look, we cannot go with this forever because we are going to extinguish, or we are going to end up having creating another problem because your body cannot support that energy deficit for too long of a time. So as a protective mechanism, it lowers metabolic rate. So this is what is the concept of adaptive thermogenesis. And I said we usually don't talk much about this, but it has a very important implication for weight loss, especially when you combine exercise and dietary restriction, because exercise increases, it forces your body to spend energy, more energy, and at the same time you restrict the intake. So you create an even bigger gap between the intake and the expenditure, and that provokes a more exacerbated response of your body to try to adjust and lower metabolic rate. Normally, this in a day-to-day basis, not specifically if you're doing exercise and diet, if you're enrolled in a formal weight loss program, but in normal conditions, because some days we eat more, some days we eat less, so there is always some adjustment that your body makes, and that accounts on average to 10 to 15% of total daily energy expenditure. Now, if you engage in a very aggressive program of weight loss and exercise, what you see is that this can go way more than 10 to 15%. It can go 30, 40, sometimes even more than 40% reduction in energy expenditure. Okay, so this is what the concept of adaptive thermogenesis. And again, I want to stress this point because it's one of the main reasons why people, when they start in a weight loss program, they have a quick loss of weight, and then it kind of slows down, and then over time it plateaus, because now you have an adaptive response that occurred in your body to say, well, we need to restrict it, to try to adjust what is the availability of energy with how much you're spending. And the importance of exercise is that with exercise, even though your body might be trying to reduce its and it's actually reducing energy expenditure under resting conditions, when you exercise, you force the body to increase energy expenditure. So exercise has that ability to force the system to increase energy expenditure, even though under resting conditions, which you have no control over, your body itself shuts down energy expenditure. So there is this antagonistic response. Exercise forces the body to spend energy, but when you're off exercise, your body is under control, and then it shuts down energy expenditure. So that's what makes it very difficult for people in the long run to maintain weight loss. Not only that, to continue losing weight and to maintain weight loss over time. So most people tend to gain back everything they lost because the adaptation that the body causes reduces energy expenditure, and then over time what happens is that now if you go back to your previous eating habits, or if you stop exercising, or if you're not restricting energy expenditure, you gain weight quickly. And that's why people tend to gain weight more so than what they had before. So again, this adaptive thermogenesis mechanism is very important for us to understand how what happens to weight loss, not only in terms of how much you lose, how prolonged the weight loss is, and how you maintain weight loss over a long period of time. Okay, so this is again adaptive thermogenesis. We're going to go back to this because there are some important aspects that we are going to discuss in the next few slides, but it has a lot to do, it's intrinsically related to weight loss, but it will come back in a different way soon. So the last one that I want to discuss is physical activity, and I think this is an obvious one because it refers to all voluntary movement performed on a daily basis. In other words, everything you do. If you get up from your chair and you go to your fridge to get a glass of water, you're moving your body. If you go out to walk, or if you go to school, or if you go to work, every time that you have any movement in your body, if you're doing dishes or if you're doing any kind of physical movement, you can spend energy. And remember, I think I mentioned this before. There is a division between physical activity and exercise. Physical activity is any kind of a movement that spends energy. Exercise is usually more structured, and I think we defined this well before. We said that was every time that you program or you prescribe exercise, such as what kind of exercise you're going to do, how often, how intense, and the duration of the exercise. These are all specific parameters that you establish on a particular exercise prescription. So that's why we differentiate exercise from physical activity, because physical activity is any random movement that you make, but exercise is more of a structured way. In the end, what this all means is that anytime that you have either physical activity that is a spontaneous movement you do on a day-to-day basis, or if you go in a planned exercise program, in both ways what you're doing is increase energy expenditure by muscle contractions. And it's generally responsible for 15 to 30% of the total daily energy expenditure. It depends on what kind of physical activity you engage in or your profession. If you're a teacher, for instance, you spend very little energy because the kind of activity is basically sedentary. Or if you work in an office, if you're a lawyer, if you're a doctor, if you're an engineer, usually most of these professions, they require very little physical effort. So they are usually considered sedentary. So there is a very little energy expenditure associated with that kind of professional activity. Now, if you are a mailman that you have to walk around delivering mail, that increases your energy expenditure because what you do on a day-to-day basis involves, or your profession involves, movement. Now, if you're an athlete, you can spend way more than 15 to 30% because, or you can represent more than 15 to 30% of your total daily energy expenditure because you spend 6-7 hours a day exercising. If you're a football player, or if you're a tennis player, or if you're a swimmer and you have several hours a day that you dedicate to exercise, then you can spend more than, or the energy spent with exercise can go beyond 30%. In some cases even 60%, 70% of your total daily energy expenditure. But it's in a very limited number of people. Most people that we know, and if you ever work in a gym or any place, or if you're a personal trainer, you're going to prescribe exercise to general population. Most people, they are those that are involved with very sedentary activities on a day-to-day basis. So in terms of physical activity, you're going to add very little to it. I mean, if you do 1 hour of exercise in the gym, you may spend another, let's say, in best case scenario, you're going to spend another 500, 700 calories a day. So it's still relatively limited in terms of how much you spend in a day compared to someone who has a profession that requires physical effort throughout the day. Okay, but physical activity is that part, is how much you spend in terms of any movement you make on a day-to-day basis. So with that, I think we can stop here for today. I want to continue next time and really discuss, go back more to that idea of adaptive thermogenesis. I also want to discuss in the context, in an applied context, lean body mass, how much energy you spend, or your lean body mass spends, and how it relates to total energy expenditure, and how also your adipose tissue regulates your metabolic rate. So we are going to discuss that in more detail, and we'll do this next time. So thanks for watching, and talk to you soon. Bye now.